Go.
Time for physics.
Featuring.
Period 9 All-Stars. Alright, let's go over here. We're putting pausing in place, see which way the electric field went. So we did a couple of them yesterday. Let's do maybe one or two more. Let's put posi over here. We can put posi over here. Where will posi go? Remember, wherever posi goes, so goes the electric field. What will posi feel from this one?
Repulsion.
Alright. Strong or weak?
Weak.
Relative to this one.
Oh, strong.
Why?
Closer.
There you go. So it's going to be repelled. And then this one, what will it feel?
Weak.
Repulsion.
Weak, also repulsion, plus plus, in this direction. So, the resultant of these two is something along the lines of not straight this way, but a little bit tilted up from that one. And that's something like maybe this direction. Can you start to get an idea of the resultant electric field of this one?
Yeah.
If you ignored this one, it would just be straight away, but this one has the effect of pushing it a bit off to the right. So instead of going straight up, you're really going to be a little more to the right. Okay, now, in this visualizer, we can put posis on here. Basically, this is showing what we were just practicing. If we put posi over here, wherever you put posi, near a positive charge, look at posi go! Posi doing the dip. Now, if you get posi in close to the positive charge, of course it moves away with a high acceleration. Farther away, the electric
Can
field
you use
is
your
weaker.
keys again, Hoss?
You're making a video, right?
Oh, you are?
Yes. That's all right. Keep it going. So there it is. There's posi running away. Now, I'll show you something over here. So,
Sorry.
we take our positive charge. We'll put one here. Let's put some field lines around this. If you remember, we did this simple positive charge. Desk jockey, please put us back to the smart notebook. Up here, you saw it moved away from the plus. Let's go back over. Here, these are also moving away from the plus. Now, what if we added another plus here? What do you think would happen to all these field lines? So they're all running away. Think of little posi as they're all running away from this plus one. This is plus 1 million protons concentrated right here. If you put another plus over here, let's say, right here, what do you think will happen to these?
Big move.
Will they want to come toward this? Will they stay where they are? Or will they want to get away?
Get away.
Let's see. Boom. So you have that same radial pattern, except now it's pushing away. So as they move out, oh, I don't want to be near you either. And so we can put the field lines in around this one as well. And notice, you get this pattern that's kind of like the single plus, but then as it approaches the others, it says, no, I don't want to go there either. Bring us back, please. And so if you put all these together, what you end up with is something like this. Yes, it would want to come out this way, but it actually gets diverted by the other one. So you get, and you'll see these lines will actually trace along the little ones that we actually marked. There's your plus plus electric field line. How would the minus minus pattern look?
Same.
Almost. What's the difference? Pattern would actually be quite similar. What's the difference for minus minus though? What would posi do?
Going in, though.
Yeah, posi likes to come in toward a minus. All right, cool. Let's do this one over here. Put posi in the middle. Probably don't even need to do the individual effects. What will the plus do to posi?
Repel.
Push it to the right, and the minus? Pull to the right, so you actually go directly across like this. Let's look at a couple of individual spots. Let's try this spot, and this spot. And let's see what we get going on over here. Okay, this spot, what do we get? The plus will
Go to the right.
Repel it. The minus will.
Go forward.
And so what's the resultant of these two?
In the middle, right?
Yeah, downright and upright results in just plain old right at this point. Can you tell this one without even drawing in the arrows?
Yes.
Upright, downright, also? Right. And let's check this one. Of course, this will repel, but it's proximate, it's close, so the repulsion will be stronger. And here, the attraction, there's some, but it will be weaker. What's the resultant of those two?
Or towards down, right?
Yeah, so not quite like this, but a little more tilted out because of this guy. You're looking a little more like this direction. And so how does this all come together? Pop us back over to that internet window, please. And so if we clear all, we can put our plus back over here. We put some field lines around it. Now, we're going to add a minus charge. We'll put that over here. What do you think these field lines will do? Basically, what would posi do if you put a minus over here? Will they come toward it? Will they run away from it? Or will they ignore it? All right, let's check it out. Ah, and in fact, they did. Instead of just running off into space, they said, ooh, we'd like to end up on a negative. We could add a couple field lines on this side. There's your picture. Kind of an alien-looking insect or something like that. So we'll go draw this in over here, and actually, this does follow the pattern we started. It comes up off this one, then to the right, and then back down into the negative. Down, over, into the negative. This one, two. This one, two. And you'll find the paper runs out. So you go here, imagine where it would continue. There it is. Over here, imagine where it would continue. Back over here. One coming out this way and one coming this way. Good? All right. Now, parallel plates. You notice G and H look a little different than A, B, C, D, E, F?
Yes.
I've been saying point charges, point charges. Well, these down here are not point charges. So we'll do a partial. We're not going to do H today, we'll do G today, even though they are very similar. Put a couple posis in here. Where are they going to go?
Down.
Hey, you see that? Plus will send them down, minus will send them down. In fact, if you look at this posi, these pluses directly above push down, these push down this way, these push, so they're having the diagonals, all of them together will result in down. The negatives do the same. Pull over here, pull this way, over here, pull this way. The resultant will be just down. Same thing here, same thing over here. This is actually a very common question. Draw 4 field lines between the parallel plates. Make sure you touch the surfaces. Now you get out to the edges over here. Yes, you still have the down, but notice there are only pluses above right, which tend to push down left. There are no others over here. Down here on the bottom, there are only minuses below to the right, which tend to pull that way. So you'll actually get curved field lines around the edges. We call these fringe effects. Fringe, meaning the edge. You'll take physics, college physics, and I don't mean AP here, I mean when you're in college, and they'll teach you about these infinite parallel sheets, because they don't want to deal with these fringe effects. Okay, what about a couple below the plates and above? Where will posi go down here?
Up.
Yep. Up to the plate. And then when you're above it,
Down.
you might want to say down, but in fact it is also up, up, up. So we'll leave H, we'll look at that on Monday, give you a little refresher on this. Note, electric field lines never cross each other. You took earth science, and in earth science they talked about contour lines. Those never crossed each other either. And fairly easy extra credit if you think about it is why they never cross. Alright, let's look at question 50. Point P is near a negative charge. We can put posi at point P. Where will posi go?
To the left.
And that's the direction of the electric field. Boom, done. That's enough for now. Finish 9-5. There are 4 questions I said you shouldn't do from last night. Do them tonight. And do June 2015 multiple choice.